Okay, so I'll give you guys a moment here to go on GitHub and pull the data and the notebook. Okay, so it's a fairly big data set. nycflights.csv. This is one that shows up in from dplyr, but I've exported it as a CSV file, and we should be able to do this, okay? And this will give us a chance to kind of actually use pandas in a little bit more of a real-world-ish analysis scenario here, okay? So it should be up on GitHub. Okay, yeah, so I added NYC flights here and draft 0403. All right, so like always, we're going to start by loading NumPy and pandas, and then I'm also going to go ahead and import matplotlib pyplot, okay, as PLT, and this is also standard. I haven't talked about this directly. We'll have a separate notebook on matplotlib later. But I think it's been covered a little bit briefly in DataCamp, so I feel comfortable loading this up, okay? And so the first thing we're going to do is we're going to do read CSV, okay, with pandas. Pandas.read CSV, all right? And this takes a little bit of time, but it gets loaded. And we can take a look at just the first few rows in the data set, okay? And so by default, it gives us a range index, and it loads up all the data. We got year, month, day, departure time, scheduled departure time, departure delay, arrival time, scheduled arrival time, arrival delay, carrier flight, tail number, origin, destination, airtime, distance, hour, minute, and time hour. Okay, and so these are New York City flights from the year 2013, and we've got all of this information here. Okay, and we can kind of get some information about this, all right? And so we see some of these things are stored as ints, some are stored as floats. Okay, so why would, this is just a question, why is scheduled departure time an integer and departure time a float? So if we look at this, scheduled departure time says 5:15, which I'm going to assume means 5:15 in the morning. And the departure time is 517.0. What do you think is going on here? Okay, it says the scheduled departure time is 5:15, departure time 517.0, departure delay 2.0. 5:29, 5:33. Just looking at this, what do you think? So this says 600, so I'm assuming scheduled to leave at 6 a.m. Okay. So it's not actually an integer, it's a time, but it's written kind of like this. So this sounds like 5:45 in the morning, this sounds like 6 a.m. Okay. Our departure time is not written as 5:44, it's written as 544.0, 544.0. What do you think? Why is this a float? Okay, take a look at the info again. How many values do we have for scheduled departure time? 336,776. Departure time, we got 328,521. What's going on now? What's that? Not all flights departed, right? So this is kind of the docket, right? The airport has a schedule of which flights are scheduled to take off, but not all of them take off, right? Some flights get canceled. Bad weather, whatever. There's some reason the flight gets canceled. So why do we have to make it a float then? We have to make it a float to make it, to be able to have missing values, right? So missing values are nans, N-A-N, not a number, and not a number only exists as a float in Python, okay? So in Python, not a number is a float. And so if you've got missing values, you're gonna have, it's gonna be a nan, okay? And And so the scheduled times can remain as is, okay? But the actual departure time and the actual arrival time have missing values in them, so they become floats, okay? So 1004 is probably 1004, but it appears as 1004.0, okay? All right, so that gives us a sense, all right? And then, you know, if we look through some of these things, okay, some of these times, we're going to represent times as they get represented as these kind of integer things, but they're not actually integers, right? So this one, for example, scheduled departure time is 1455, which should be 14:55, 2:55 p.m., right? So that's what it is. And 2:55, but it gets recorded this way. So we want some way to be able to turn this into a time that actually makes sense, right? Because if a flight takes off at 14:55, scheduled to take off at 14:55, but then its actual departure is at 3 o'clock, 15:00. What is 15:00 minus 14:55? So if the time is 3 o'clock and it was supposed to take off at 2:55, how late was it? So if something's scheduled for 2:55 and we take off at 3, we were 5 minutes late, right? However, if we're recording it as 14:55 and 1500, then that difference is what? Is 45 minutes, okay? You're gonna get a difference of 45. So that's gonna be a problem, right? Because time is on a 60-minute cycle, not a 100-minute cycle. So treating this like this is gonna be a problem. So we need a way to deal with that, okay? And then if we also look at some stuff, we've got tail number, origin, and destination, and they show up as object, okay? And so object is basically allows us to work with string type things, but with missing values, okay? So that's what I write. So I got, so the fact that decimals are appearing, so we got basically nans, and they have to become floating types. So Python strings, pandas uses object, which allows for missing values. Okay, so what we're going to do is we're going to convert all of these things, the departure time, departure delay, arrival time, arrival delay, and air time, which currently appear as floats. We're going to import them as object, basically strings, okay? We're going to import these things as object type, and then they won't have any decimals. They're going to just appear in their raw form. So if I take a look at this, now scheduled departure time is this 5:15, 5:17. So we got rid of the decimals that appeared under departure time. Is that right? And then and if we look at the the last few, okay, these things which are missing values, they're still preserved as nans. Okay, so they still appear as missing values, even though they're kind of like treated like strings, but they're object type. Okay, so when you import a fairly large data set, you might have to deal with situations like this. Okay, so this is just some basic cleanup. Okay, Pandas has a function that allows us to create dates. Okay, and so what I'm going to do is I'm going to take each of these columns that say year, month, and day, and I'm going to combine them into a single date, okay? And the date, the way you create a date using to date time is you give it a dictionary. You say the year is going to come from the column flights.year, month is going to come from the column flights.month, and the day will come from flights.day. Okay, and if you feed these things into a dictionary, it's going to create a new column. And so how did I create a new column? Basically, I'm just saying flights date, okay? And so this is basically a name that does not currently exist in the data frame. And so when I do this to a pandas data frame and I say, here's the name of a column that doesn't exist, it's going to go ahead and create a new column for us, okay? So we're going to go ahead and do flights date is equal to this date object. And if I take a look at this, now there's a new column at the end that says date, okay? And if I ask for the info on this, I guess I haven't done that. But if you ask for the info on this, you'll see it recognizes this as a date, right? So if I do okay, so it recognizes that here we have a date time object for the date, okay? Not just object, not just strings, but it has combined them successfully as a date time object. All right, and again, the problem is that right now we can't do time differences between columns. We've got 6 o'clock and 5:45, and in time-wise, that's a difference of 15 minutes, but if we do 600 minus 545, that's a difference of 55. So that's going to cause some problems. So to deal with this, I'm going to basically run I'm going to extract the minute and the hour from this column here, okay? So we're going to take one of these columns. So here we're going to do departure time. We're going to take the departure time, and what I'm going to do is I'm going to say the last two characters, 1 and 7, will be the minute, and then the other characters will be the hour, okay? So like for here, I'm going to pull out 04, that will be the minute, and the 10 will be the hour. And here, basically everything but the last two characters, the 5 will be the hour, the last two characters, 44, will be the minute. Okay, so how can I do something like that? So what am I doing here? Let's go through this. So I'm saying flights, take the column departure time, and then I do a bracket, right? So I'm saying subset this, so we're only going to do this to what? The ones that are not null, right? So this is only going to apply to the ones that are not null, okay? So we're not dealing with any null types. And then what do? So take the departure times that are not missing, and then what we say is treat it like a string, okay? So I'm just linking methods together using the dot, right? So we start off with flights, which is the data frame. Dot departure time pulls out that column, which is going to be treated as a series, okay? And that series object, I'm going to treat as a string. And then what does this do? String bracket -2:. I'm slicing a string, right? So I'm slicing the string so that I'm only just pulling out what? The last two characters. So the last two characters become departure minute, and then everything up to, but not including the last two characters, become the departure hour. Right? And then I'm going to just print these out. Okay? And what we get is we get series. Okay? Now here's the great thing about dealing with pandas series. In R, what would happen if I said only keep the ones that are not null? So if we have like 1,000 things in our original data and 50 of them are missing, then the resulting vector will only have 950, okay? And there's no inherent ordering. So if I try to just paste that 950 back into the data frame, we're going to get a mismatch, right? Because the original data frame has 1,000 rows. This new vector I'm giving has only 950. With pandas, because everything has an index, okay, it's going to keep the index and it's going to say, you know what? Here's I have a data for row 39. I don't have anything. Row 40 is missing, but I've got something for row 41. And so when I append that column to the original data, it's going to line everything up by the index, okay? And it works out beautifully. Okay, so now I can do this, all right? I can do create a date time object, okay? A column, and we're going to use pandas date time. We're going to take the column year, the column month, the column day, and then these are the series that we just created. All of these have indexes associated with them. So even though this one has entries for like all, all the rows, and this one only has entries for the ones that were not null, it will still line up appropriately because the index matches everything up accordingly, okay? So it takes a moment to do it. We can look at the first 10, okay? And then the last ones, it doesn't create a problem, it just says these are not a time object, okay? We get NAT, not a time object. And so all of these things, and this looks correct, right? So if we look at the original data, we had January 1st, 517, January 1st, 533, January 1st, 542, and indeed, they became times, 517, 533, 542, okay? So this works out very well, okay? Okay, so what we want to do is we want to do this for basically all the columns. Departure time, scheduled departure time, arrival time, and arrival delay, or maybe not arrival delay, but we want to do that. Okay, so this is my advice always, is that once you get something to work, there's a temptation to just take the thing and copy and paste it and just change the column names, right? Like, okay, I did it for departure time, so let's just copy and paste this, and where I have departure time, let's replace it with arrival time, and then let's replace it with scheduled departure time or whatever, okay? If you're gonna, if you only have to do it once, fine, okay? If you copy and paste once, I guess that's fine. Copy and paste twice, you should think of writing a function, and if you're gonna copy and paste it 3 times, definitely turn it into a function, okay? That's the whole point of functions, is that so you don't have to copy and paste the same thing and just change one of the column names, okay? So here, I'm gonna do this thing called convert time for a particular column name. So we're gonna do this and we're gonna extract out the minute, the hour, and it's basically the exact same code, right, that I have back here, flights.departure time, except I'm saying flights, and then plug in the column name, and we're gonna make sure we're only gonna do it for those that are not null. Pull out the first 2 characters and last 2 characters of the minute and the hour, and then put them all together as a date time and return that thing. So that's gonna be the creation of a new function here. All right, does that make sense? The creation of a function. So you should always try to do stuff like that rather than copy and paste. Okay, so let's go ahead and try this function that we created, convert time. We're going to apply it to the column departure time. Okay, so it runs, and we can take a look at kind of the first 10 rows, the last 10 rows. Indeed, it looks like it's worked correctly. All right, and then so we'll go ahead and now we'll just apply the function to the other columns, scheduled departure time, arrival time, and scheduled arrival time. So it takes a little bit of time because it's got to go through like 336,000 rows for every single one of these things. Okay, so it does that. And then we're going to use pd concat, okay, pandas.concatenate. So this allows you to add extra columns to your current data frame, right? So a lot of these things, like I haven't covered the exact details of all of these functions in a separate notebook, but here's a good example that I think, is a good reference for doing stuff that is halfway complex, okay? So we're going to concatenate all of these columns, okay, and I give it the dictionary, the name of the column that I want, and then the actual series values that we're going to do, and we're going to concatenate it axis-wise, okay? And so the result is going to be this thing, okay? We created a data frame with all of the stuff, 517, 515, 830, 819, and then we're going to join this date times data frame, okay, with the flights data frame, okay? And so when we do that, now we have this full thing, okay? We've got all of the departure times as, integer and object types, and then we have the actual things here, departure time and arrival stuff and all of that. I did it quickly here, but this was tough to figure out, okay? It was like when you play with data, you're going to run into situations where it's not behaving the way you want, right? You try to do calculations, you run into stuff, and you're going to have to go through and you're going to have to kind of figure out how to fix these situations, okay? And so this is an important part. And I don't know if you call this just data cleaning or if this is just part of the data analysis process, but it is, okay? And it's just taking things. The data set is pretty clean. It's just some of these values are in formats that aren't conducive to the kinds of analysis you need to do, and you have to be able to manage all of this stuff. Okay. All right, I'm going to go ahead and just get rid of the year, month, day things because this is redundant information. So I can drop those columns, and if I ever want to get the month out, okay, I can take the dates column. The date column, which is over here, right? This is the date column, and a date column has its own date methods. Okay, so you say you've got take this column date, and the .dt says treat it like a date-time object, and there's a certain attribute for a date-time object. There's an attribute called month, and you can pull out the month, or you can pull out the day. All right, so I can do this, and it pulls out the month. I can do flights.date.dt. And we can pull out the day. And then I'll just pull out the tail on these. Okay, and this is for like the 30th and things like that. At the bottom of our data set. Okay. Well, we'll see how much time we got. I got 2 minutes. Okay. So some just very, very, very basic analysis, and I probably will run out of time here. But maybe our first question is, how many carriers are there, and how many flights exist for each carrier, right? So here I'm going to just go to the column carrier, okay, and they all have these different codes. So UA is United, AA is American Airlines, B6, I don't know what that is. I think that's JetBlue. DL is Delta. All right, so you can just do unique, all right, and you get all of these things: United, American, B6, Delta, all of these other things. WN is Southwest, and I don't know what these other things. You're gonna have. There's a airlines.csv, which I don't think I've uploaded yet. Okay, so this is gonna run into an error. I'll upload that. Okay, and we can ask, how many unique airlines there are. We've got 16, right? If you want to see how many times the thing appears in your data, you can use the column value counts. Okay, so we've got that. So United has about 58,000 flights. B6, I think that's JetBlue, has 54,000. Okay. Let me go back to my Spring folder. All right, and I'll upload the airlines file here. Airlines.csv. Okay, so this is kind of the dictionary of what they are. Okay, so 9E is Endeavor and B6 is JetBlue, and so these are the names of all of these things. So we can take this data frame with the names of the airlines and join it to this thing that we just created, carrier counts. Okay, so carrier counts is this, and join will automatically say, oh, you've got the carriers here. Okay, so on carrier counts, okay, when we did value counts, what kind of object is this? This is a series, right? And how many columns do I have in a series? Yeah, so if I ask for the index, okay, it's the carrier counts, the names of the carrier is the index, and the values themselves are the values, right? This is the series. So there's really only one column. So anyway, when you do join, okay, so right here, the index column, I've specified carrier as the index column, okay? Rather than if I didn't specify this, what would happen? So if I got rid of this index column stuff, what would happen when I import this? Okay, carrier would be a column, the name would be a column, and we would get a range index of 0, 1, right? 0, 1, 2, 3. So we don't want that. We want the carrier to be the index, and that allows me to do the join, okay? By doing the join, it's going to look and match up the carriers. So even though this series shows up in a different order, this thing, it will match up the values accordingly, okay? Which is really nice, all right? Okay, we'll go ahead and we'll end here for today. Have a good weekend, you guys. We'll see you guys on Monday.